Section 12.2a is about rational expressions. A rational expression is an algebraic expression whose numerator and denominator are polynomials. So we're going to have fractions, but other than just numbers and letters, we're going to have polynomials in the denominators of the fractions. That brings us to another idea, an idea of excluded values. An excluded value is a value of a variable that results in the denominator of a zero. Let's look at this first example. Here's our rational expression. Notice it has polynomials on the numerator and the denominator, so it's rational. We've got to find what value we could put in for m that would create a 0 on the denominator. Now, I'm not just talking about plugging 0 in for m. If I plug a 0 in for m, 0 minus 6 would make the denominator negative 6, and that's not a problem. We instead have to find the value that will create a 0 in the denominator. So what number can I put in for m that will make a 0? The answer is 6, because if I put 6 minus 6 on the bottom, I get a 0. Now for right now, I really don't care what we do with the top. The top is not of a concern to us. Really what we care about is the denominator of a 0. You cannot have zeros in the denominator of a fraction. And if a 6 causes me to get that, then I say my excluded value, call it EV, is a 6. Here are some more examples where we have to find the excluded values. Hopefully you're able to just look at this denominator, 3 plus a, and realize that a cannot be a negative 3. But I do want to show you how we should find the excluded values so that when they get harder, you'll know what to do. We're going to take the denominator, we're going to set it equal to 0. Back in Chapter 8, we learned about something called the zero product property, and that allowed us to set polynomials equal to 0 and then solve them. So here I'm going to solve this for a by subtracting 3 from both sides, and we get a equals negative 3. So we know that a negative 3 plugged in for a will create a 0. So we say that an excluded value here is negative 3. That's the value that a cannot be. Over here, take 2x plus 6, set it equal to 0, and then solve for x. So 2x equals negative 6, divide by 2, so x equals negative 3. What that means is if I put a negative 3 in for x, I will create a 0 in the denominator, which is impossible. You cannot have zeros in the denominator, so we should exclude the answer of negative 3. Here's an example we have to find an excluded value for, but this time I don't think you're able to do this one in your head. You can't just think about what number x should be to make a 0. So we're going to have to use this idea of setting it equal to 0 and solving. Well, back in Chapter 9, we learned that if you have a trinomial and you want to factor it, you need to use the diamond. So here I'm looking for the two factors of 6 that will add to give me a negative 5. Looks like negative 6 and 1. So we could write this as x minus 6, x plus 1 equals 0. And now it's a lot easier to pick out the excluded values. So here x could not be a 6. Here x could not be a negative 1. So we'll say excluded values 6 or negative 1 are both excluded. There's actually two excluded values here. Last one here, looking for excluded values, n squared plus n minus 20. We'll set that equal to 0 using the diamond. I need two factors of negative 20 that add to be 1. 5 and negative 4 I think should work. So we're going to get an n plus 5 and an n minus 4. So now that it's factors, it's easy to see what values I should not get for n. N should not be a negative 5 here, and n should not be a positive 4 here. So we'll say the excluded values, the values that we cannot include in our solution would be those two.